Alrighty, everybody. I just got the okay to start our last planetarium show of the day here at the Morrison Planetarium. So I'm going to be putting away our space trivia questions and that important message because now we're going to be heading into the unknown. Ooh. And good afternoon, everybody. Welcome to the Morrison Planetarium. Really quickly, I just want to introduce myself. My name is Christian. I want to be your planetarium presenter. And just a heads up, I'm not just a voice coming out of the walls. I'm actually a person, and I'm standing right behind you. Hey, how's it going, everybody? Don't hurt your necks. Look forward to the dome before you. That's where the whole show is going to be. Everything that you see in purple is going to be one enormous screen. Thanks to the help of 6 different projectors hiding throughout our planetarium dome. And folks, I'm very excited for y'all to join me right now because you're in for a special treat because we're about to do my favorite planetarium show called Tour of the Universe. And with Tour of the Universe, the show is completely live. You're going to hear my voice for the next 30 minutes. And what we're going to be doing, we're going to be starting off pretty close to the Earth, and we're going to zoom all the way out to the very edge of the observable universe. Hopefully, by the end of the show, you won't have an existential crisis of where you are in space. But I do need to forewarn you, we are pretty small in the grand scheme of things, so just a heads up. And before we get started, I gotta go over some quick house rules just so that we're all on the same page. We have an enjoyable time in here. First off, there's no food or drinks allowed in. If you manage to bring any snacks or beverages, make sure those are put away till the end of the show. We want to keep the theater nice and clean. Also, if you happen to have any cell phones, smartwatches, tablets, anything that produces really bright white light or loud sound, now is the perfect time to turn them off, put them away for the next 30 minutes, as those take away from our planetarium show. And it's very distracting, not only for you, but for the folks sitting behind you. So, again, if you have a cell phone right now, make sure those are put away before the show starts. And also, folks, if you need to leave early during our show, you're more than welcome to do so. All we ask is that you exit the top of the planetarium. That's where you're going to find the exits before, during, and after the show. So when in doubt, always make your way up the stairs, not down them. If you have trouble climbing the stairs, don't worry. We'll have a staff member escort you to a lower exit once the show has finished up. So just stay seated once the show's ending. And last but not least, folks, this show is very immersive thanks to our 75-foot dome above us. If at any point during the show you start to feel overwhelmed, you start to experience motion sensitivity, there's a really quick and easy trick to ground you. All you got to do is close your eyes, take a few big deep breaths, and your brain will remember that you're sitting in a planetarium in San Francisco and not hurtling across the universe. Hee hee hee. But otherwise, we're just waiting for those 7 phones to get put away, and then we'll get started. Once again, just put away those cell phones, and we'll start the show. Muchísimas gracias. All right, let's get started, y'all. Sit back, relax, and let's begin our tour of the universe. Alrighty, everybody, we're going to be starting off pretty far away from planet Earth, but not too far. We can see the city lights start to pop up just down below. But we're going to be starting off at this spacecraft right in front of us called the International Space Station, or the ISS for short. And a lot of people tend to ask me, hey, Christian, what's the International Space Station? I hear about it all the time in news and articles, but I don't really know what it is. Could you explain it for me? Well, of course. The International Space Station is a research facility, a laboratory that orbits around the Earth. And pretty much they conduct all sorts of science experiments up here that they wouldn't be able to on towards closer to the Earth. And a bunch of countries came together and helped construct this. So they built this bit by bit. And the different types of science experiments that they'll conduct up here are things like what happens when you try to grow plants in space? Do the plants grow the same? Do they grow differently with less gravity? What happens when you try to spark a match in space? Does the flame act the same? Does that act differently? And one of my favorites is where they had 2 identical twins. One twin lived on Earth for about a year. The other one lived on the International Space Station for a year. After that year, they compare and contrasted. Turns out when you live in space for a long period of time, you tend to age a little bit slower. But not only that, you also lose a lot of muscle because you don't have gravity constantly working down on those muscles. So if you plan to live in space for a long time, remember to exercise daily. And also, folks, the International Space Station looks pretty big on our screen right now, but it's not too big in actuality. It's only about the size of American football fields. If you've never been to an American football game, don't worry. You can also use the entire California Academy of Sciences, the museum we're sitting in right now. That's about how big it is. And not only that, folks, the International Space Station is going incredibly fast. It's going a whopping 17,000 miles per hour, where it orbits once around the Earth every 90 minutes, and it experiences 16 sunrises and 16 sunsets a day. Whew, how romantic. And also, folks, this looks pretty far above our planet Earth, but it's not too far either. It's only about 225 miles above the surface of our world. So 225 miles, that's not too bad. That's like going from San Francisco to Santa Barbara, a nice little road trip to get away with the family for the weekend. And to tell you the truth, this is as far as we put humans into space nowadays, folks, only 225 miles above the Earth, because going into space is very expensive. You got to build yourself a rocket ship. You have to account for all the rocket fuel. You're going to need so much rocket fuel. You got to escape the Earth's gravity. And then once you acquire that, you have to account for all the food, water, and all the air you're going to be breathing while you're up here in space. So the bill gets quite costly quite rapidly. But the International Space Station is just the first stop on our tour of the universe. So let's slowly leave it behind, because now we're going to see it slowly disappear to the city lights down below. And before we lose track of it, I want to add a nice little orbital path so we can see it as we zoom away. Alrighty, everybody, we're now looking down at our planet Earth. And to let you know, the space program that I'm using here in the Morrison Planetarium is something that you can download and use at your house. The space program that I'm using here is something called OpenSpace. So if you go to your favorite search engine, type in OpenSpace Projects, you can find the link where you can download it and fly through space just like how I am. It's so much fun. But just a heads up, OpenSpace is not entirely finished. It's in its beta phase. So we may come across a few bugs and glitches. If we do, I'll point them out for you and hopefully we can look past them. And also, folks, OpenSpace uses a whole lot of processing power. So if you have an older computer, I wouldn't recommend downloading it. It may overwhelm it. But if you got something new or a gaming computer, give it a try. It's a lot of fun. But if you're a person like me that doesn't want to download anything, we also have another great alternative called NASA's Eyes. Just like the human eyeball, type in NASA's Eyes to your favorite search engine, and you can fly through space just like how I am without having to download anything. And it's just so much fun. So again, we have OpenSpace and NASA's Eyes. But let's leave the Earth behind, because now we're going to be making our way over to our nearest natural neighbor to us in space, the Moon. Now, we humans have been to the Moon before, but that was between 1969 and 1972, thanks to NASA's 6 Apollo space missions that brought a total of 12 incredibly lucky guys to walk on the surface of the Moon. They got to conduct science, and of course, they had some fun as well. They got to play some golf up here. But again, last time we sent humans to the Moon was 1972, a little more than 50 years ago. But don't worry, folks, we humans are planning to make a return trip back to the Moon in the next few years, thanks to NASA's new space mission called Artemis. Pretty much with Artemis, NASA wants to send humans to Mars, but before we send humans deep into our solar system, we got to figure out exactly how we're going to live out here in space. So the Moon is the perfect stepping stone to figuring out the logistics exactly how we're going to be doing that. And what's also really neat is that NASA is going to be sending the first woman to the Moon, but not only that, they're also going to be sending the first person of color to the Moon, but not only that, they're also going to be having lunar bases throughout the Moon. Pretty much our technology has improved greatly in the last 50 years, and we're able to conduct a lot more science in a much more compactable size. So we're able to do so much more. And one place that we definitely want to set up a base is the South Pole of the Moon, because we found ice there, and that's going to be very helpful for setting up bases. We can do so much with ice. We can melt it, use that for water, or some other for other capabilities as well. And maybe we want to go set up lunar bases throughout the Moon that we weren't able to check out 50 years ago. Maybe we want to go take a look at some collapsed lava tubes on the other side of the Moon. Maybe we want to go take a look at some really high mountains or anything that we like. And what's also really neat is that they're going to have a space station orbiting around the Moon at all times called Lunar Gateway, kind of like the International Space Station that we just saw. So if anything was to happen while these astronauts were on the surface of the Moon, they can head to that space station where they would be safe. But again, folks, we humans should be heading back in the next few years. Look out for any news about Artemis. And folks, when we look at the moon here from Earth, sometimes the moon feels incredibly close. It feels like you can reach out your arms and touch it. But the moon's really far away. It's about 240,000 miles away from the Earth. Whew! 240,000 miles. Some of the adults in this room may have a car with that many miles on it. And if you take better care of your car than I do, you can even imagine driving to the moon if you drove for about 4 months nonstop, going about 80 miles per hour. Although I wouldn't recommend it, the roads out here are poorly maintained. He. And from here on out, folks, we're going to need to use a more useful measuring stick because at this scale, using miles is kind of like using inches to describe the distances between cities because space is so big. Astronomers use a more convenient measurement known as light speed. And light travels at a mind boggling speed of 187,000 miles per second. That's roughly about 300,000 kilometers per second. So while it took the astronauts more than 3 days to reach the moon, traveling faster and farther than any human has done so ever since, it only takes light 1.5 seconds to cross that distance at the speed of light. That's kind of like a short pause in conversation. But at last, folks, it's time for us to leave the moon behind. So everybody say bye-bye, moon. See you later. So cute. And now, folks, we're going to be seeing the moon and the Earth in their orbits as they slowly disappear. And in fact, before we lose track of them, I want to add some nice little planet trails. You can easily lose stuff out here in space. And on our journey, we're going to be traveling much faster than the speed of light. We're going to be traveling at the speed of the human imagination, thanks to help of computer models like OpenSpace showing the most accurate images and information available to us. And now, the nearest star to us, the sun, should be coming into view any second. So here comes the sun. Do, 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 do. There it is. And folks, the sun is also incredibly far away from us. It's about 93 million miles away from the Earth. 93 million miles? Whew, that's nothing compared to the speed of light. In order for sunlight to cross that distance, only takes sunlight about 8.5 minutes at the speed of light to cross that 93 million miles. So not too bad, only 8.5 minutes. But now that we have a nice bird's eye perspective of our solar system, let's get a quick refresher of what's in it, shall we? Right in the middle, we have our star, the sun, the biggest thing. The closest planet to the sun, we've got Mercury, then we have Venus, and then Earth, that's us, and then Mars. These are the rocky terrestrial planets. These are places where we can actually land a spacecraft on. And then past the orbit of Mars, we have the main asteroid belts, and this is what it would look like if to highlight all the asteroids in our asteroid belt. There is a lot of them. And then past the main asteroid belt, we have the really big planets, the gas giants, the Jovians. We've got Jupiter, the biggest. Then we have Saturn. And then we have our icy gas giants. We got Uranus, the funny one, and Neptune. And of course, we're going to add everyone's favorite and lovable dwarf planet, Pluto. So here's the orbit of Pluto. It's the top left of the screen. And a lot of people don't realize that Pluto hangs out here in this outer part of our solar system called the Kuiper Belts. And you're probably wondering, what's the Kuiper Belt? I've never heard of that before. Well, folks, this is the Kuiper Belt. Yeah. So this is pretty much a second asteroid belt past the orbit of Neptune. And mostly we're going to find out here are icy asteroids and short period comets that don't stray too far away from the sun. And pretty much we found all this stuff in 2006 because our technology has improved. Our telescopes got better. We're able to find much smaller objects much further away. And we're able to find more than 400 objects out here in the Kuiper Belt region. And as our technology gets better, maybe we're going to find more stuff in our own backyard in our solar system. And that's just what's so cool about science. As our technology gets better, we're able to learn new things and readjust of what we used to know. But I want to put away the Kuiper Belt because that's just a whole lot to look at. And right now on screen, I'm going to be adding on the different spacecrafts we sent out in the 1970s to explore our solar system. So on screen, we have the trajectories of Pioneer 10, Pioneer 11, Voyager 1, and Voyager 2, and the latest of them all, New Horizons, which did a quick flyby of Pluto in 2015. All these spacecrafts are traveling fast enough to escape the sun's gravity and leave our solar system behind. But even the most distant of these robot adventures, Voyager 1, has not traveled as far as light travels in a single day. In order for sunlight to travel all the way out to the orbit of Pluto, it takes sunlight about 5 hours at the speed of light. 5 hours, not too bad. But folks, let's leave our planetary scale behind because now we're going to be heading out into interstellar space, the space between the stars. Distance now becomes so immense, it's going to take us about 4 years at the speed of light just to reach the next star system to us, the Alpha Centauri. And if my calculations are correct, Alpha Centauri is going to be the bottom left or bottom right star system to us. So we're right here in the middle. Look a little bit down to the right. You're going to see a star moving. That's Alpha Centauri. And again, 4 years at the speed of light to get to the next star system. But that doesn't really put into perspective of how long it would take us humans to travel that far. Well, folks, if you're getting a rocket ship today, left planet Earth, make your way over to Alpha Centauri. It's going to take you about 8,500 years. Whew, and that's just a one-way trip. But let's stop and consider whether humanity has made its presence known, because now we're going to be heading inside something called the radiosphere. So again, we're now inside the radiosphere, and this represents the current limits of the most distant radio signals humanity has ever broadcasted, or rather leaked into space. And it extends about 90 light years in all directions, emitting out from the Earth. This first began in the early 1930s with strong radio waves, early television, radar signal, and then later the detonation of atomic weapons. All this stuff is emitting electromagnetic radiation strong enough to escape the Earth and the Earth's ionosphere. And humans were broadcasting well before that, but the earliest radio was not quite powerful enough to escape the Earth. And since all these signals are electromagnetic, they are traveling at the speed of light. So this is kind of like humanity's electromagnetic footprint in the universe. And of course, the radiosphere is always expanding at the rate of 1 light year per year. So is anybody out there listening? And right now, folks, I'm going to be adding on screen some markers. These many markers represent some of the many thousands of stars astronomers have discovered over the last 30 years, which has at least one or more planets orbiting around them. We call these planets exoplanets, and we're looking for any of them that are Earth-like with conditions suitable for life as we know it. So far to date, we found 5,000 exoplanets in a nearby vicinity to us, 5,000 other worlds besides our own. Whew, that's a lot. And that 5,000 number is going to be increasing as the years continue because we have space telescopes where their whole purpose is to find as many exoplanets as possible. But to ask if any of them are Earth-like with conditions suitable for life as we know it, well, we can't answer that question quite yet. Pretty much new space telescopes are being developed right now, so they're just on the drawing board. So it's going to be a few years before those are constructed and then launched into space and then conduct science. So we got a little while before we can answer that question. But the more important point here is that quite a few of these planetary systems are within that 90 light year limit of our radiosphere and could have potentially received our signals. However, since radio waves travel at the speed of light, if there is anybody that's out there able to listen in and answer back, the communication delays between hellos could be decades in time. Now, to give you an example, let's say we live in a star system on the far left side. Let's say this one over here. We find an alien civilization somewhere towards the middle. Let's say over here, 60 light years away. We shoot them a text message. We say, hey, we live here. 60 years to get to them. They listen in. Another 60 years to get back. That is a 120-year conversation in the making. Whew! And I can barely wait for a text message from my friend. And of course, folks, planetary systems beyond the radiosphere more than 90 light years away have not heard from us yet, but eventually they will, as the radiosphere is always growing, but it becomes weaker as it does. And I want to put away the exoplanet markers, but I'm going to leave our radiosphere up on the screen because as huge as humanity's electromagnetic footprint is, it is nothing compared to our Milky Way Galaxy. Alrighty, folks, we're looking down at our Milky Way Galaxy, and can anybody see their house from here? Just kidding. And folks, our Milky Way Galaxy is incredibly large. If you wanted to cross it from one side to the other, it's going to take you about 130,000 years at the speed of light. Whew, that's really big. And not only that, our Milky Way is so huge, we estimate that there's at least 300 billion stars in our galaxy. If our recent discovery of so many exoplanets just within our small neighborhood within this vast star city is any indication, there could be billions of planets and potentially millions of Earth-like planets throughout our single galaxy. And before we leave the Milky Way, I want to show you what it looks like from a sideways perspective. You're going to notice that we live in a flat spiral disk of the Milky Way. And that's going to come important because when scientists and astronomers want to learn about the universe, it's so much more easier for them to point their telescopes galactically north and galactically south, instead of looking through the plane of the Milky Way, which has planets, stars, gas, debris, things that block their view of the universe. So keep that in mind. We like to point our telescopes galactically north and south. But folks, the Milky Way Galaxy is only one of many hundreds of billions of galaxies that comprise the known universe. So in this giant leap, every single point of view that you're now going to see no longer represents a star, but rather the location of an individual galaxy. Each galaxy containing hundreds of billions, perhaps trillions of stars. And we live in a local galaxy group, which contains about 30 galaxies, large and small. Also includes the nearest large spiral to us, the Andromeda Galaxy, only 2 million light years away, just next door and heading right for us. We're going to get to know it pretty intimately in about 5 billion years, so mark your calendars. And folks, we zoom so far back now that you're going to now realize that galaxies are not evenly distributed throughout space. Instead, galaxies like to clump together in large groups and clusters, or they like to avoid each other where there's very few galaxies or no galaxies at all. So we can see a nice galaxy cluster right over here. We can see another galaxy cluster over there. Very few galaxies towards the top or no galaxies at all. You can kind of think of galaxies like people. They like to hang out together or they like to avoid each other. And we got to give thanks to an amazing team that worked at the University of Hawaii who compiled this amazing galactic map over decades of time. So them and a bunch of astronomers worked together to create this amazing map that we're flying through right now. So big shout out to that team and studying at the University of Hawaii. And also, folks, before we go much further out, I do want to show you the brand new image released from the James Webb Space Telescope. And if you don't know what the James Webb Space Telescope, this is the brand new space telescope that replaced Hubble, and it just released its first 5 images, and they are spectacular. And I want to show you this specific one. Alrighty, folks. So what we're looking at is the James Webb Deep Field, which was the first image that was released. And folks, there are hundreds of galaxies in this one photo, which is just so amazing. And what's even more amazing is that in this picture, it occupies a very small portion of the night sky. If you were to pick up a sand grain off the floor, lift it out about arm's length away from you, that's about how big the frame is where the James Webb took this photo. So a really small portion of the night sky. And what's amazing is that what we're seeing is a bunch of galaxies, and right in the middle, there's a galaxy cluster. There's a bunch of galaxies all squished together, and you're going to see kind of like this bubble effect where there's galaxies warping around it. There's so much distortion in the space and time that this galaxy cluster is causing the background galaxies to kind of warp and kind of look like strips of bacon. In fact, some people are starting to refer to this stuff as space bacon because it kind of looks like bacon in space. And what's also amazing is that this image that we are seeing right now only took 12 hours to be produced, whereas the Hubble's Deep Field image took 21 days. Whew. Our technology, folks, has improved greatly, and I'm very excited to see what else the James Webb will be releasing in the years to come. But let's put that away for now, because now we have automated systems that are mapping even the most distant galaxies. Folks, we're about to see the very large-scale structure of the universe. And remember, folks, every single point of light that you're seeing is an individual galaxy, not a star. And just a heads up, the universe is not shaped like a bow tie or a butterfly. Remember when I mentioned that we live in a flat spiral disk of the Milky Way Galaxy? Well, if we were to line it up, it would line up just down in the middle, like so. So again, we like to point our telescopes galactically north and galactically south. But astronomers still want to make sure that there was galaxies through the plane of the Milky Way. So we have this nice purple survey right here. You'll notice that they were still able to find galaxies, just not as much and not as far. Pretty much we have to wait for our technology to improve, and once that happens, we'll be able to map out these areas that haven't been mapped out yet. So it's just a matter of time. And folks, it looks like we're running drastically low on our tour of the universe. 30 minutes is just not enough time, so let's continue pressing on, because now we're going to be encountering these really distant, faraway objects known as the quasars. And the quasars are going to be these orange dots at the very edge of the large-scale structure. And the quasars are short for quasi-stellar radio sources. And these blazing objects are all billions of light years away. So we're looking so far back in the depth of time and space that the most distant quasars represent the universe at a much earlier age. We're nearing the very beginning of galaxy formation. In other words, with the quasars, we're viewing a sort of awkward, gawky teenage version of the universe. And before there was a teenager, there was a baby. So let's press back to a time before quasars, before planets and stars and even galaxies began to form. Folks, we're about to see the very edge of the observable universe. So here we are, folks, at the very edge of the observable universe, and what we're looking at is something called the Cosmic Microwave Background Image, or the CMB image for short. And all evidence indicates that the universe that we live in is about 13.8 billion years old. And this is all data compiled by Planck and other radio telescopes. And the picture that we're looking at is of a very baby version of the universe, only 380,000 years after the Big Bang occurred, where space and time began. And what we're looking at is not a typical photo either. Instead, this is a temperature density image, where the light echoes of the Big Bang are color coded with the lighter areas corresponding to the hottest, least dense regions, and those darker areas, the coolest, densest regions. These fluctuations in temperature and density are extremely tiny and vary no more than 1 part per 100,000. But these really small differences eventually gave rise to a large scale structure of the universe that we saw moments ago, that clumping and clustering of galaxies everywhere. Figuring out just how that happened is one of the larger challenges for cosmological research today. Though our view here is of the outer edge of the known universe, folks, the earliest light visible to us, that radiation actually persists all around us. It permeates the universe, stretching and cooling as the universe expands over billions of years of time. But folks, we've traveled as far back as the law of physics can physically allow us to go, so we only have one direction left to go. That's going to be back towards planet Earth. So let's find a nice entry point through all these quasars and galaxies, and let's make a return trip back to planet Earth, y'all. Alrighty, folks. So, folks, we're crossing an expanse of over 13 billion light years. We present you with this view of our universe and the latest in cosmological and astronomical information. We're covering eons and observing objects billions of light years apart. And we live in a golden age of astronomy with new generations of telescopes and spacecrafts that are extending the reaches of our eyes and preparing for the eventual race between the advancement of technology and the accelerating expansion of the universe. With that thought, I want to remind you all that astronomy is for everyone. You don't need to be a rocket scientist to enjoy the beauties and wonders of our universe. All you need is the night sky, and if you can, get away from the lights of our cities and look up. Even a good pair of binoculars makes for a decent first telescope, and there's astronomy clubs all around the world that invite people just like you to look into their telescopes and peer into the great beyond, allowing you to partake in the wonders that our universe has to offer. Now, astronomy as a hobby can offer an endless supply of satisfaction, and I do hope you'll join us, those who dream amongst the stars. But it looks like we just made our way through our Milky Way Galaxy. We made our way straight into that radiosphere, and we're heading for our solar system. And it looks like we're about to pass the spacecrafts we sent out in the 1970s to explore our solar system and the Kuiper Belt and the orbit of Pluto. And we're making our way to the third rock from the sun, our homeworld, planet Earth. All the people that we know and learned about in history all lived on this one planet. And it looks like we're about to pass the orbit of the moon, the furthest we've ever sent humans out into space. And folks, as we make our final approach back to planet Earth, this is going to be the end of our Tour of the Universe show. And I want to thank y'all for stopping by and watching with me today. I hope you did enjoy it. But hey, look at that. We made it back home safe and sound. And that's it for now, folks. Thanks for stopping by.